First of all, good evening, everyone. Let me introduce myself. Yeah, this is Sai Kushal, a upcoming final year undergrad student in ocean engineering at IIT Kharagpur. Currently a research intern at Maritime Research Center, Pune. Yeah, today I will be presenting our ongoing research work on tuna fisheries in the Andaman and Nicobar Islands. Let's begin by understanding why these islands matter so much, both ecologically and strategically. Yeah, Andaman and Nicobar, a maritime powerhouse. These highlands cover nearly 660,000 kilometers square. That's about one third of India's EEZ. And strategically, they lie close to the Malacca Strait, one of the world's busiest shipping lanes. And they are also biologically rich with 4,500 plus marine species, 220 endemic, and stunning coral ecosystems with over 1,000 coral species. And here, as you see, as in left side, this is the EEZ map with a Andaman and Nicobar highlighted. And on the right side, it is a strategic choke point location of the Andaman and Nicobar. So the region is not just strategically vital; it's an ecologically treasure trove. Let's now understand its economic lifeline. Fisheries, the beating heart of Andaman and Nicobar Islands. Fisheries are the backbone of life in Andaman and Nicobar, both for sustenance and livelihood. It catches volume rose dramatically from 44 tons in 1950 to 3,850 tons by 1982. It will showing how quickly marine harvesting evolved. And the region holds 1434 fish species with over 400 commercially viable. And more importantly, the total fish stock is nearly 240,000 tons. It's about 6.2% of the India's marine fishery resources. And in that, tuna alone contributes 60,000 tons, but we only tap about 4,420 tons. That's barely 7% of the potential. This as you see in the left side, this is the annual marine fish catch in 1950 to 1982 and the distribution of capture methods. And as you see in the right side, this is a tuna catch utilization in the Andaman and Nicobar Islands. This large gap between the potential and actual catch is where new strategics can truly make a difference. Yeah, that's why riding the waves of blue economy transformation comes to bridge this gap. The government launched as major initiatives like PMMSY, the Blue Economy Mission, and the Tuna Cluster Project. And the innovations in sea cage farming, hatcheries, and seaweed cultivations are now scaling up. And the ONGC and oil have begun exploratory drilling in the Andaman Sea, especially at sites like Vijayapuram 1 well, and due to its similarity with oil-rich Southeast Asian basins. On the digital front, tools like PFZ advisories and the Samudra app are improving real-time decision making for fisheries. And as you see in the left side, the Samudra app it will provide real-time PFZ advices by inquiries. And as you see in the right side, this is the CKS farming setup. But despite all these developments, one major component is still missing. It is detailed spatial data for tuna fishing. That's why this unlocking the tuna bounty. We know that 60,000 tons of the tuna are available, but we only 7% is tapped. Why? Because there is no mapping of how ocean conditions like SST, sea surface temperature, chlorophyll, or salinity impact on the tuna growth or presence. Fishermen are essentially navigating blindly, which leads to fuel wastage or low yield and even ecological risk. Here, what is our solutions we can make? Our solution was a growth model that uses oceanographic parameters to predict tuna productivity in space and time. And now that we have framed the challenge, let me explain how we are building this method. The cracking the tuna growth. We mainly focus on the big three tuna species: bluefin tuna, yellowfin, and the skipjack. We are using a black box model instead of simulating tuna physiology. We map how parameters like temperature, salinity, DO, currents, and the feed availability affect growth rate. And the scientific literature shows that the tuna growth follows a bell-shaped curve, peaking at 28 to 29 degrees Celsius. And as you see in the left side of your screen, the scientific graph it is showing the bell-shaped curve, the growth rate versus water temperature. And our model is trying to replicate this behavior so we can identify the Goldilocks zones for optimal fishing. With that setup, we have started simulations. Here, how they work, simulating growth. And our current focus is now on the testing model with historical ocean data from Andaman and Nicobar. By calibrating inputs like SST and chlorophyll, we simulate growth behavior and generate spatial productivity maps. There is still work in progress, but we have planned a GUI interface that will allow fisheries managers and researchers to explore results interactively. And as you see at the left side, this is the conceptual flow of the modeling tuna growth from environmental input to spatial insights. And so, what does this mean in terms of real world impact? Let's look at that next. Unlocking the tuna treasure hole. This tool will help fishermen locate high yield zones and reduce fuel costs and avoid overfishing and directly boosting catch and income. It also supports the PMMSY objectives and helps unlocking the remaining 93% of the tuna resource. It's not just about the yield. By enabling smarter harvesting, we also enhance the food security and the coastal resilience. Let's now look at how we plan to take this prototype to platform. The chart in the course ahead. We are refining the model with seasonal current data and monsoonal variations. And by using satellite SST and ocean color data sets, we aim to map the full EEZ and identify hidden hotspots. And we are also planning field validation with inquiries to ground truth our predictions. The ultimate goal is GUI platform giving users from fisheries to researchers the power to make the informed, spatially aware decisions. So, how does this fit into India's long-term marine strategy? The charting the path forward. This work is a step toward data-driven fisheries governance in the Andaman and Nicobar region. By merging environmental modeling with visual decision tools, we help realize India's blue economy vision. Our approach supports ecosystem-based resource use with benefits for both communities and conservation. Before I close, I would like to quickly reflect on how this work is different from the past efforts. That's why this comes from the gaps to game changer and the advancing UDA through smart fisheries. In the past, tuna management lacked spatial mapping. PFZ advisory were used, but without specific environmental models. Our work brings in the parametric environmental modeling, a black box model approach, and a GIS interface. It is designed to integrate with national platforms like UDA. We also plan a field validation and cross-agency collaboration, which has not been attempted at this scale before. Yeah, that's why we believe this can be a game changer for sustainable tuna fishing and ocean governance. And thank you for giving me the opportunity. Sincerely, thank you, and Mercy.